will be continuing with the practice of a few numericals on the calculation of hardness of the water sample. So let's start with it. Today's numerical says that 100 ml of water sample has hardness equivalent of 12.5 ml of 0.08 normal MgSO4. What is its hardness in ppm? That is parts per million. First, let's try to understand the question. The question is saying that I have a water sample, and what is the volume of my water sample? 100 ml. So I have 100 ml of water sample, but I don't know what is its hardness. How much concentration of salt is present in this sample? So I have 100 ml of water sample, but if I want to compare its hardness with any other sample, I am saying, or the question is saying, that it has hardness equivalent to what? Equivalent of 12.5 ml of 0.08 normal MgSO4. What does that mean? That means that if I have a solution of MgSO4 whose concentration is 0.08 normal, and if I take only 12.5 ml of this concentration of MgSO4, so the hardness of that solution will be equal to the hardness of my water sample, which is having a volume of 100 ml. Okay, so in these cases what we apply, it's very simple. We apply the normality of equation. So what is that? That is N1 V1 of my water sample. Okay, it is equal to N2V2, and what is this N2V2? This is for MgSO4. Okay. So what is the normality of water? I don't know. So I keep it as N1. Volume of water, yes, it is 100 ml given in the question over here. Okay. Coming to the MgSO4, normality is given as 0.08 normal and volume is given as 12.5 ml. Right. So from this I calculate the normality of my water, that is 0.08 into 12.5 divided by 100, and that comes out to be 0.01 normal. So this is the normality of my water. Still I am not having the hardness. Okay. So how do I calculate the hardness? You know it very well. It is expressed in milligrams per liter or parts per million. Okay. So my hardness will be equal to what? It is equal to the normality of my sample into the equivalent weight of calcium carbonate. This is the hardness. Okay, why only the equivalent weight of calcium carbonate, and why am I not dividing it by equivalent of weight of the salt? Because here I have normality, and normality considers the equivalent weight of salt. Already it is there in the normality. Okay, because we know the formula for normality, it takes equivalent weight of the substance into consideration. So how do we further go? I keep the value of normality of my water sample, that is 0.01, into equivalent weight of calcium carbonate is what? 100 over 2. So that makes it 50, and my answer comes out to be 0.5 grams per liter. Okay, fine. And how much in milligrams? It comes out to be 0.5 into 1000. So that makes it 500 milligrams per liter, or you can also say 500 ppm. Why? Because 1 milligram per liter is equal to 1 ppm. So this is my final answer. I hope now you can solve all these type of questions which carry the normality information.